Alright, so here's our prototype, and what we want to do is get to work on the next prototype, and we want to make some improvements. And the first improvement we want to look at in this video is the travel I can get on the base. And I'll show you on the marker board what I'm talking about. Okay, so the way I want to make the base, sorry, will that work? Look at there. Okay, it's like this, with some pieces of steel bent. I've got a bender, it's an easy job, and then bolted to this steel tube. So this would be like 3/4 inch steel tube. Alright, and we want to put that on there, and then have the next steel tube bolted on there to form the actual parallelogram frame. And then that would be able to turn to our desired angle. Alright, so what that means is we want to get the maximum cut capacity that we can get. And so if we imagine this guy and then the actual rail, some sort of pin through here, the saw carriage is going to be, you know, these rails, so it can't come any further back than, you know, this pin or any of this business going on here. The saw has to stop there, the carriage for the saw. Alright, so if we want the table itself to be no bigger than 2 foot by 2 foot, what that means is we need to minimize this gap right here. So we've got to do some calculation to figure out how we can get the gap. Now what we want is a 50-degree cut. So if the saw is like this and the board is like this, this would be 45. We want to be able to go a little extra to 50 degrees. Okay? So we need to do some calculations to sort of figure that out. So let's do it. We're going to draw it out, and we're going to draw it with our pivot bar, and we want this to be the actual edge of the tube. Alright, and this forms a triangle, obviously. Okay, see that? And this would be our 50 degrees here. Alright, and what we want to know is this distance here. We'll call that X. Alright, now this distance I'm going to set to 1/2 inch, because that's the actual distance that I put the screw into the thing. So we'll just make that 1/2 inch. And this will hopefully be in the center of our 3/4 inch tube. Remember, this is 3/4. So that means that this is half of 3/4, because these are equal. So therefore that's 3/8. So you just double the denominator. So what this means is that we have a triangle like this from which to do our trigonometry. And what we do is this. We have this guy, we have 1/2 inch here, we have 3/8, oh, messed up, 3/8 here, we have 50 degrees here, and we have X for this entire side. Right triangle. Okay, and what we want to know is what X is, but we need to know what this is to determine X. And we'll call this alpha. Alright, so if this is 3/8, then that means that the sine of 50 degrees equals 3/8, oh, messed up, 3/8 divided by alpha. So if we solve for alpha, we get that alpha equals You multiply and then you divide 3/8 divided by sine 50. Okay, so we know what alpha is. Oh wait, I want to redraw that. And if we know what alpha is, and we know what we know this is 1/2, and we know this is 50, and we know this is x, we want to know what x is. So what we do is we just say, alright, trigonometry, the cosine of 50 equals adjacent, this side, alpha plus 1/2 over x. Solve for x and you get that x equals alpha plus 1/2 divided by the cosine of 50. You plug all that in and you're going to get equals 0.76 inches. And for us, we're going to roughly equal that to 7/8 of an inch. And it should work for us. In order that way we can minimize the gap and get the maximum coating capacity. So we'll see what we come out with on our actual coating capacity.